Hi and welcome to Programming Games in C for the VectreX. Let me first make a short introduction. So why I'm doing this? Actually, there are a lot of information about programming the VectreX on the internet, but most of them are focused on assembler, and I would say also more focused on experienced engineers, programmers, which do that for a long time. So my, I would say, learning curve for programming for the VectreX was kind of difficult because you have directly to start with assembler. You have to learn the instruction set for the 6809 and all the BIOS routines for the VectreX. So I've started to see what better or easier opportunity exists for creating games on the VectreX, and I've looked on some obviously other programming languages like C, Force is available, but C is where I'm coming from, C++, and so I was thinking it's really the easiest to program games in C for the VectreX. On the internet, on the other side, is a lot of, I would say not a lot, but a few good examples on how to program for the VectreX in C, but they are mixed in different dialects like the GCC C-Compiler, and not so much information about the CMOC. And it was also kind of, I would say, complicated sometimes to create the tool chain because of different versions, dependency on the OS, and so on. So I have decided to create an IDE for that. I've already done the same for the ZX Spectrum, and so the IDE is exactly the same I use there with a few extensions for the VectreX especially. So what I would make different is I want to directly focus on learning by coding games. I don't make so much introduction on BIOS or the coding set at first. We directly start coding a little game. And it should be easy to follow for a C programmer, and it should also be easy to learn for a completely beginner. The inside of all the BIOS functions I'm talking later on, probably in tutorial 2. And they're also coming in a manual, in an online manual, which will be included in one of the next versions of Classics Coder. But let's start now with part 1. So what I'm showing here is really the base skeleton of a VectreX program. At the beginning, you see kind of game screen data, so all the pragma definitions we have here. More or less, they just define what kind of text come at the beginning, how big they are, at which position, which music gets started, and so on. We will probably come back to that later in the tutorial, but at the moment, just take those or try a little bit out with different names, different years, and so on. Just be sure that you let the G at the beginning and the space here, and just take or change the name here. This means the copyright sign. So in the text definition of a VectreX, it's uppercased, and lowercase characters mean some special characters. In this case, it's a copyright sign. The next you will see is the include statement. You have to do that in every VectreX game you want to make. So it includes all the BIOS definitions, constants definitions, type defs, and so on. So that's the only thing you have to worry about at the beginning. Later on, some more will be coming, but for the moment, that's all. And then we have really kind of a simple, we call it game loop, or let's say program structure. So like every C program, we have the main function here. At the beginning, we initialize the machine, in this case the emulator, of course. Then we initialize our game, so setting the first position of an element, stuff like that. So really game initialization. And then we go in the game loop. And the only special thing on the VectreX is this call here, the wait recall. So in easy words, that's more or less waiting for the beam until it returns, it's finished with drawing, and you can start with the next, not frame, but the next cycle. More on that also when we talk about drawing. And then we just make kind of game input, we make a game update, and we make a game draw. So that's the structure like in mostly in every game loop on other platforms as well. So like you see, it's kind of easy. Of course, it doesn't show really a lot, but we have already here the text, we have the year, and then we will be ready to start the game. So let's do that at next. Okay, let's talk about chapter 2. What we do here is actually initializing the Vectrex. So we prepare the machine or the emulator to draw something later on to start our game. In contrast to traditional systems, other systems like the Atari 2600 or any other game console you maybe know from that time, we have here a vector display, and that's slightly different from how we set up the graphic, how we draw, how we go to the next screen and stuff like that. Actually, we more or less control a beam. A beam is kind of, how you can think about that like a laser pointer you control and draw your stuff on the screen. But more on that later on. So in here on that topic, we just talk about what we have to do to actually start drawing. That's not much. We set the intensity of the beam. That's a value we define here in a constant. Then we set default scale, how much all the vector drawings is scaled on the screen. And then we just stop the music and the sound we have initially started here at the beginning of our game by default. And last but not least, we define which control we want to use. In this game, in the little Pong game we create, we just use the joystick, so no button at all, none of the 4 buttons existing on the Vectrex. We just need the X and Y coordinate of joystick 1 and 2 to play Pong. And that's more or less all we have to do here. After initializing the Vectrex, we will now starting to work on our game. And as you see here in our flow, in the main loop, the first we actually are doing is to initialize the game itself. For that, we have to think about what is the Pong game all about. So we have some object on the screen. We want to manipulate them, we move them, we have some interactions between the pedal and the ball and so on. So that's actually what we are doing to implement now. At first, we have to create kind of a game object. If you come from object-oriented programming, that would look, I'm sure, quite familiar to you. So more or less, we save here the X and Y coordinate. We define a speed for every object. We define the scale for every object. And this we need later on for collision detection. That's more or less a frame around our object. So the rectangle which defines our object at the end. And then we set the game variables we need. Like said before, we have in our game a pedal, or 2 pedals on every side. Then we have the ball, I would say the most important. And we have a border, that's kind of a playing field we use in our game. And now, here in the game init part, we define all that game objects. So the X, Y coordinate, the rectangle around, the scale, and so on. We do that for the pedals, for every player, for the ball, and for the border. The coordinate system we use here, we talk about that in drawing, goes from 0 to 127, or on the other side, minus 127. But we talk about that when we talk about the drawing itself. Here it's important we set up all the game object we later use in the game. And yeah, that's more or less all we do here. So we define the game objects, we initialize them, and now we are soon ready to draw something on the screen. Before we implement now actually the drawing functionality in our game, let's talk shortly about how the Vectrex is working technically. So the Vectrex uses a vector display. It's kind of a completely different experience than a raster display, because if you want to draw a vector, you have to place the beam at any position on the screen, then switch the light on. It's kind of really, you can imagine that like a laser pointer. So switch the light on, move the beam and switch the light off. and that generates a line on the screen. And those points are glowing for a specific time. And to have really a solid picture, a solid game screen on the display itself, it's very important that you do that very, very fast. So in average, I would say it's 50 times per second. And then you have really a stable display image, which you really can actually see what happens on the screen. One advantage is also in the technology of those screens. So in contrary to raster displays, you don't have something to clean up, because everything after drawing a line is completely erased. So like I've said before, the points are just glowing for a specific time, and at the end of the drawing routine, it's done. So you don't have to clean up kind of buffer or something like that. We have already defined the game objects. We have created kind of game variables to hold those objects. Also keep in mind we define those always as static, not as const, because actually we want to change those values, of course. So it's important to not define those as const. But everything else, we should not go to the RAM. It's important that we really define those values as const. The VectreX actually has not very much of RAM. The most of the space you have is in ROM, so static stuff is not difficult, of course, to store and save, but with the RAM you have really worry about that you don't use too much. What we do here is to define the vertices for every object. Vertices, if you come from 2D or even 3D programming, maybe you know that already. So more or less that's the coordinate which define a geometric object on the screen itself. The speciality here, how we use the vertices on the VectreX, is that the first number is kind of the size, the index numbers. So we have 1, 2, 3, 4 elements, so it's a rectangle, right? It has 4 corners, and that means it goes from index 0 to index 3. So what we have here, the pedal, it's 5 pixel wide and 20 pixel high in every direction, of course. So like that, we really define every kind of object, no matter how complex or how easy it is. Here in the Pong example, of course, it's quite easy because we just have rectangles more or less for the pedals. We have a cross here for the ball, and we have kind of a rectangle around the screen for the border. So to draw them now, it's also not complicated because we have already defined the object itself. We have initialized them here in this area. And now we have defined the vertices, you remember, here on top. So we have just to create a drawing routine which we pass those two information. So actually the game object, which contains the coordinates, the speed and so on for every object, and the vertices, so the geometric definition, how we draw them on the screen. And here the drawing routine itself is now really kind of easy. The first call is zero beam, so that means we position the beam at the center of the screen, because all the coordinates we give here are relative to that. So we don't have absolute coordinates on the VectreX itself, they are all relative. Of course, that's not very optimized, but for our example, it's quite good enough. In more complex tutorials later on, we show what kind of other possibilities we have. But for simplicity, we just position before every game object draw the beam at the center, set the scale for that object, move the object to a position, all stored in the object structure, and then we just call a BIOS routine called draw VLC and pass the vertices. And we look at that now in the emulator. So what we have now is more or less we have drawn the screen, all the elements we use in the game. You see here the border, pedal 1, pedal 2, and the ball. So it's really kind of easy, I would say. But of course, it's not yet a game. We have just drawn something on the screen. So let's continue with the next chapter. So of course, for a game, that would be quite boring if we have no animations and no movements on the screen, right? So let's do that next. To move an element, it's quite an easy functionality we have to add. So we just change the x, the y coordinate every frame by the speed of the object we have defined here in our initializing routines. And that makes the ball, in this case, move, of course. Let's look shortly at that. So that's already a little bit of an enhancement, right? So we have a ball that moves on the screen, but of course, we recognize here many issues, right, for the final game. So first of all, the ball is not reflecting on the borders, so it just goes out of the screen, comes in on the other side, and so on. It even passes the pedal, and so like that, the game is not really working. But we actually draw something on the screen, and it has some movement, so that's quite impressive, I would say, for the first step and the little time we invested so far. What we do here in the next chapter is about creating kind of game logic. That's not very VectreX specific, except that we handle a little bit different the coordinates, like I've said initially, when we talk about the screen size and also about how it works, and kind of drawing some stuff. But actually that's plain C programming, I would say. So what we do first is now we implement a logic that the ball we see here don't go out of the screen anymore. So that's the next step. The goal is now really to let them bounce. And as you see here in the code, that's quite easy. So we just check if the ball is going out of the screen with the next movement, which is done here. And if yes, then we just inverse the speed of the ball to the opposite direction. And we do that for every side, for both sides, actually top and down. Of course, we have to implement or call that function here in game update. So we call here check ball position. And yeah, I would say that's already a progress we do with that little piece of code. Let's see. So you see the difference? It looks much more better now, and also much more in the way we know Pong from implemented games, arcade or whatever machines. So what would be now the next we have to work on? Actually, we draw something. We have the first movement of objects here in game update, but here we have still something very important empty. So that function is still nothing. The game input, I would say the most important for every game, right? So if we go to the next chapter, then we will actually work now on that. So what we want to do in the game input is we want to choose the joysticks to actually position the pedal for player 1 and player 2 up and down. That's quite easy now with the helper functions that are already implemented in Classic Coder for VectreX. So when you ask for game input, we just check the state of the joystick. Then we see if joystick 1 goes up, down, same for joystick 2, up, down. And we change the position of the pedal, right? So that means whenever the joystick goes up, we go up in Y direction. If we move the joystick down, we go down in Y direction. And of course, we don't do that endlessly. So we want to check if the pedal is still in the screen. And for that reason, I've created two helper functions. Pedal is on top or pedal is on bottom. And those two functions do exactly that. They just check if the pedal is already at the end of the screen, so on top of the screen, or on bottom of the screen. So that's actually all which is done in this routine and here in game input. And of course we have defined here the pedal speed. So we can increase that, we can decrease that. So you can define your own speed here by just changing the number 4, which is assigned to pedal speed. But let's see what we have now. So you see, we can actually move the pedal. It doesn't go out of the screen. You can do the same for player 2. Doesn't go out of the screen, but it still goes through our pedal. So the ball itself is not controlled by the pedal, but actually we can move the pedal. So we're coming closer to our game. What we need next in our game is what we call collision detection. So we want to control what happens when the ball actually crosses the position of the pedal, so when they collide. And to do that, we improve our game update function by a method called collision detection. Of course, we have to implement that function as well. So what we actually are doing here is we check if two game objects are colliding. I explain later on that function in more detail. If they collide, in that case, if the ball is colliding with the pedal of player 1, then we revert the direction of the ball. So it just goes in the other direction. And this here is to be really sure that the ball is going also in that direction. So that means depending on the speed we set, it can happen that the ball is always over the pedal and it needs some more movements to go out of the position of the pedal. So that is kind of a safety routine, I would call it, to be sure that the ball is really go away from the pedal itself. And we do that, of course, for player 1 and for player 2. The more important function is now a function we can use in general. That's the reason why it's here. So it's kind of a game object helper function. And what it does, it's more or less, it detects if object 1, in our case it's the ball, with object 2, that's either pedal 1 or pedal 2. And then it really compares the position of them. So if the ball is before the pedal, after the pedal, below the pedal, or on top of the pedal. And if not, if all those conditions are valid, then it returns true. So that means whenever we have a collision between those two elements, we get true back to the calling functions, otherwise it's false. And that's all we need actually to detect if objects are crossing each other. So let's see if it works. So if I go now up and down, you see, big difference. It's actually cool, right? I can now play the ball to the other direction. Oh God, I missed it. But yeah, I have a game now. Same on the other side. And it even works like that. Perfect. That's actually what was the goal of that chapter. So now we have almost a working game, right? We can draw the objects, we can move them, we can even detect if two objects are colliding. So now we have a almost working game, right? But it would be still kind of boring, I would say, if we don't have any scores, we don't have winner, we don't have loser, actually. So the most important, which is now still missing, is kind of a scoring system. And that's what we implement in that chapter. So first of all, we have to include an additional file, the standard library. That standard library is almost the same like on every other platform which supports C, so that's kind of string manipulation, input, output, and so on. The only difference here on the VectreC is you don't have any commands or functionality which actually are reading or writing to the console, because yeah, there is not one, right? But to implement now the scoring system, it's kind of easy, I would say. Now we have two new variables where we store the score of each player, score player 1, score player 2. And of course, we have to implement kind of a logic when it counts for one or the other player. The logic itself, we can easily do now with the function we have already written here. So with the check ball position. So remember, we have the function which verifies on which direction the ball is, on which side the ball actually is, and here we test about is the ball on left or right side, and that's exactly what we need, because if the ball is going on the right side, it's a score for player 1. If it goes on the left side, it's a score for player 2. And that's all we do here. We just increase the score for every player. But of course, that's now just internally. What we need now is a function to draw that on the screen. So we have to enhance our drawing routine, which you see here. So before we just draw the game object, but now we also draw kind of the scoring system itself, the score points for every player. That's also easy when you remember about drawing an object itself. We zero the beam, so position on 0, 0 in the center of the screen. Then we create a string variable with the current score, and we just print it out on the screen, the same for player 2. So let's see how it works. Yeah, I already got a score. I get it back. Zack. Player 1 is already 2. Now we have to do something on the other side. Okay. Great, it works. So for now we have almost a complete game, right? There are some minor stuff which we still miss. So for example, we don't have audio, we don't have sound. That we do in one of the next tutorials. Also, we miss some stuff on the game logic, right? Because the ball is not starting in the center after we lose on player 1 or player 2. And also we can make some optimization or kind of improvements of the gameplay itself, kind of make it more difficult, limit the number of points like in a real tennis game and stuff like that. But more important for that tutorial was that we have now a full working game, and we can increase the functionality and also the way it works in every direction. So we can really make now a complete game. But that's part of tutorial 2. As you see here in the current version, we have still some glitches, right? So sometimes the ball is not working correct, or it changes direction too early, or sometimes it even misses kind of position. And that's difficult to find on the original VectreX, that kind of problems or issues. You maybe know that from other platforms. There on modern platforms we have debuggers, we have all the possibility which we have not here, at least not for now in this kind of IDE of emulator. But what we actually have is kind of helper functions. So what I'm doing is normally I have here some functions to dump the state of an object. So the X and Y coordinate, I dump them on the screen, do that for the ball and for the pedal. And then with the help of the emulator, I can just say, okay, stop now here and let me go to the next position frame by frame. And like that, I see directly, okay, that's the X and Y position, and I can verify my algorithms, my functions, if they really are correct. What I'm also doing very often is to write the code, the logic code at least, on Mac, on Linux, whatever, and test it out there, because the behavior, the calculation, that works one by one on every platform. It's just the drawing which is different, and of course the user input. But you get the point. Actually, it needs a little bit more time maybe to find some errors, but at the end you have all the possibilities here as well. So I hope you have liked the first tutorial about programming the Vectrex in C. I know it's not perfect. I will actually improve, I hope, a lot over time with recording the tutorials itself. But I hope at least content-wise you like what you have seen here, and you have a great starting point now to begin with your first own game project. Of course, it's quite simple what we have done so far, but be sure I will continue that tutorial very soon. So I hope I have chapter 2 ready in January, where we go more than on sound and enhanced drawing functions and stuff like that. And of course, we make much more complicated game projects in future. So for now, I hope you have enough food to work over Christmas time on your own games. Give me a thumbs up if you like, and let me know in the comment section what you would like to know more in detail, and what kind of tutorials you would like to see in future. Have all a great Christmas time, and hopefully see you soon. So for now, I hope you have enough food for So for now, I hope you have enough food to work on your cut.